Hello everybody. Um this is Hafsa's Math Academy. Hi. Let me just put the phone down so I can record properly. So as you can see from my screen, this is my YouTube channel. You can follow if you want. I'm a very bad teacher, so don't rely on me. And I actually did film a video for exercise 2.1, but there were some complications and I'm not able to upload it anymore. So we're just going to start by exercise 2.2. Now, as you can see, I'm using a laptop. I don't have a notebook with me right now, so I'm just going to be recording the screen of my laptop and recording my voice as I go along. On this side, on the left side, I have your guys' math book. And on the right side, I have exercise 2.2. So this is like the solutions for it, and again, since I don't have a notebook, I'm just going to be going through a solution, and since my laptop is a touchscreen, I'm just going to write along my notes and explain the solution to you as I go. Sorry for any background noise. My family is a circus, and let's just get into it. Sorry if the audio is weird. I'm recording this from my phone. Please don't judge me. So yeah, let's just get started. So matrices and determinants, right? Right. Where's the exercise? Let's find the exercise. That's 2.3. I went too far. There it is. Exercise 2.2. Is there anything I have to explain to you before? Let me check. Okay, so the basic things that I feel like you all should know from 9th and 10th is, addition of matrices, subtraction, multiplication, transpose, the different types, like, a scalar matrix or an upper triangular matrix. You should know these things from 9th grade. And I did explain it in the previous video, but again, I can't upload it because of reasons. Exercise 2.1 is for MCQs, so you guys have to remember that if you want to do good MCQs, you have to actually do the first few exercises. A lot of people will tell you that, oh, there's no need to do the first exercise, it's fine. It's really not fine. You have to do them. Because your MCQs, as far as I'm concerned, I'm pretty sure they're 25 marks in the paper, so that's an entire 25 marks you could lose. So yeah, make sure you guys do 2.1 in your own time. It's very easy, so you won't have to do anything too crazy. So we're just going to start off by 2.2. Now what they're teaching in this is scalar multiplication, which is pretty easy. You guys, if you're a physics student, you will know this in physics as well, basically what it means. Addition of matrices, like I said, you should know that from 9th and 10th. Subtraction, multiplication, and then we have two laws. The commutative property of matrices with respect to, WRT means with respect to addition. So commutative property is basically just saying, again, I'm going to write on my screen, A plus B should equal B plus A. Okay? That's all it's saying. That's with respect to addition. With respect to multiplication, it's going to be, let me just erase that. Oops. A multiplied by B is supposed to equal B multiplied by A. Now we're going to figure that out later if that makes sense. But yeah, that's with respect to multiplication. So yeah, again, you guys should just know that all you have to do is these questions will either come in long or in short, where they'll just give you the law and they'll say that prove that A plus B is equal to B plus A. Or they say that prove the commutative property with these two matrices. They'll give you an A matrix, they'll give you a B matrix. So yeah, that's what's going to come in the question, and you just have to solve left hand side then right hand side, just add them both. Now we also have the commutative properties of matrices with respect to multiplication, like I just said. So again, it's just going to be A into B equals B into A, which I'm pretty sure is not valid. Yeah, as you can see in the book that I have open, this is a, whoa, I can't use the highlighter. This is a non-valid formula. So the commutative property is not valid when it comes to multiplication. Again, they're going to ask this show if the commutative property with respect to multiplication is valid within these two matrices. Then you have to prove it, and you're going to see if they're both the same answer, then it's going to be valid, which it won't be. And if they're both not the same answer, you're just going to say, no, the commutative property is not valid within these two, blah, blah, blah. Verification of this law. Alright, now A into B transpose is equal to B transpose into A transpose. You guys should know what transpose is. Very easy. You just turn the rows into columns and the columns into rows, I guess. But yeah, so you guys should be able to do this exact same thing as this. Alright, just left hand side, then right hand side. And if it is the exact same thing, just say yes, it is verified, blah blah blah. And you have a bunch of examples here, so we're not really going to solve those because there isn't really any need to. Symmetric and skew symmetric, you all should know as far as I'm concerned, because again, that was a ninth. But in case you all don't, I'll just explain it over here real quick. Symmetric is when, let me change the color, this is not a very nice color, I'll change it to blue. A is equal to, so suppose you have a matrix A, right, and it's a simple identity matrix. Again, you should know the types of matrices, right? So in this case, if this is symmetric, A should equal to the transpose of A. That means that this matrix will be symmetric. So let's test it out. This is our matrix. Let's take the transpose of it, which is just turning this row. Hold on, let me just make my matrix. You have to turn this column into a row, and then you have to turn this second column into your second row. So let's test it out. It's going to be A transpose, this column into a row, this column into a row. Now, as you can see, both of our matrices are the exact same. So that proves that it is symmetric. The original matrix is equal to the transpose of the matrix. So that means that it is a symmetric matrix. Now, skew symmetric is basically the same, but we're going to add a negative sign. All right, so suppose we have the same matrix, okay? And let's test it out by first of all taking it transpose, which we saw last time was the exact same. Now we have to take the negative of the transpose, which is just multiplying all the values on the inside by a negative sign. Now if you solve that, you will see the answer is not the same as the original matrix. So this entire thing, this matrix A, is not skew symmetric. Sorry, let me make that red. It is not skew symmetric. Now, my way of remembering if a matrix, my way of differentiating between symmetric and skew symmetric is just a little bit of a trick. This is symmetric, as we all know. Now, you know, like a skewer, right? Like a shish kebab skewer or something, you have all your food on here. To make it skew symmetric, so skewer, you're just going to put a skewer through the original formula, which is the negative sign in this case. But yeah, that's how you just remember the difference. That was a quick little explanation in case anyone had forgotten. Now, let's continue into the actual real things. So again, we're just proving a bunch of different formulas over here. If they're right, then you write them that they're verified, and if they're not, then you're going to say it's not verified, therefore this formula is not valid. So starting off with exercise 2.2, they're asking us to construct a matrix A in which we have this minor element of order 2 by 2. Now all of you should know what the order of a matrix is, all right? If we take this random matrix, I'm just going to quickly explain. We're going to write the order is equal to, we are going to multiply the number of rows. Oh, sorry, I did not know that was going to happen. The number of rows, which is in this case 2. And for rows, we're going to put R with the number of columns, which did not work on my screen, but you get what I mean. In this case, I'll put the columns as K. You can use C if you want, or you can use any other letter. In the book, they use M and N, but I prefer to use R and K for two very specific characters. But anyways, so number of rows into number of columns. The amount of rows we have is 1, 2. And the amount of columns we have is 1, 2. So 2 into 2 is going to be our order of this matrix. Now, we can have different types of matrices, like 1, 1, 1, 1, 1, 1, just for example. So the order of this matrix, again, the number of rows, which is 1, 2, 3, so it's going to be 3 times the number of columns, which is 2. So the order of this matrix is going to be 3 by 2. There's also some matrices which only have a singular value in them, for example, 0, so the order is going to be 1 by 1. But yeah, again, just a quick little briefing on what an order of a matrix is. Again, this is going to come in your MCQs. This was taught in exercise 2.1, so yeah, do that for your MCQs. So yeah, we have to construct a matrix A with the order of 2 by 2, for which we're given this minor value, okay? This matrix A that we have to construct has to consist of the minor value. Now in part 1, the minor value that they've given us is this, I plus 3j over 2. Now how are we going to construct this? First of all, if you should know how to study minor values. I'm sorry. We're given 2 by 2, right? So we have the numbers 1 to 2. When we're constructing our matrix, our minor values is going to be denoted by A. Okay, a 2 by 2 matrix, we all know that it always has 4 values. First of all the possible combinations between 1 and 2, we're going to start from over here. Okay, so the first combination I can make is 1 with itself, 1 and 1. Second combination I can make is 1 with 2, 1 and 2. Now we've completed our combinations with number 1. We're going to do number 2 now. So the first combination I can make with number 2 is 2 and 1, all right? The second one is 2 and 2. Okay, I hope that makes sense. It's a really weird way to explain it, but that's why they're basically forming the matrix like this. You're going to be questioning, oh, why do they have 11, why do they have 12? It's just a combination between the two numbers. If they were asking for a 3 by 3 matrix, we would again have a big matrix, and we know by a 3 by 3 we have 9 values on the inside. Sorry if my handwriting is really weird. I'm writing on my laptop screen with my finger. First of all, we have 3 numbers, right? So we're going to do 1, 2, 3. First, we're going to start with number 1. All the possible combinations we can make with this number. We're going to do 1, 1, all right? Then 1, 2, then 1, 3, okay? Now we're going to go on to 2. The first combination we're going to make is 2, 1, then 2, 2, then 2, 3. It's like we're counting up with each number at a time. Okay, now last one, we're going to take our third one, counting up. 3, 1, this is our first combination. 3, 2, our second one, and then 3, 3. It's our third one. So that's how you're going to make it for a 3 by 3. I hope that makes sense. That's why they've just made this matrix as it is with all of our minor values on the inside. This is our elements, our elements on the inside. That was a really bad way to say it. Okay, so as you can see, this is one element, right? And over here they've given the element the name of ij, but here, since we actually have numbers to put into place, we've put I as 1. See how we've put the first value, which is denoted as I, over here as 1, and the second value, j, is also 1 in this case. So we're going to calculate our first value of our matrix using the values 1 as I and 1 as j2. So they gave us this little formula over here, and we're just going to input it into that. A with the element 11 is 1 because I is equal to 1, plus 3 into 1 because j is also equal to 1. And then you're just going to do all of your solving, and you're going to find that the answer to the first element of our matrix is 2. So if we make our matrix over here, we can put the first part in as 2. We're going to do the exact same thing for all 3 of the other values. Over here you can see that I is still 1, and j in this case is 2. That's where you're going to take I is 1, j is equal to 2, you're going to solve it. In this case j is 2, as you can see. And the answer is 7 by 2. So you're going to write 7 by 2. Same for the third value, which is 21. Sorry, I blocked that out. It's 21, so I is 2, j is 1. As you can see over here, they've solved it, and our third value is 5 by 2. Our last one, I is 2, and j is also 2. So we're going to solve it, and our value is 4. So we just input all of those values in, and you can see that we've made our matrix A with those values. That's what you're going to do for all of the other ones. In this one, this formula is different, but you're going to do everything the exact same way, except you're just going to change the formula that you're solving. If we go down now, again, the formulas are just changing. That is question number 1. Okay, now moving on to question number 2. Construct a matrix B, okay, with the elements inside being corresponding to ij, bij, of the order 3 by 3. Now, in the previous question, I already taught you how to make this 3 by 3 matrix that they've made over here. So I hope there's no confusion on how you're supposed to make this. And again, they've just given you the exact same formula. So it's the exact same method, except there's a bit more work. In the last one, we only had it... Oopsies. In the last one, we only had it till... It's not working now. Sorry, till these. Sorry, cut out that B13. We only had this, right? But now we have several more values to do. So again, it's just the exact same thing. You're going to take your I and J values by the corresponding digits and come in, and you're just going to input it into the formula, and you're going to solve for each of your values. Does that mean that?
There's no more, so this is all you can get.
Okay, thank you. Okay, so I hope that makes sense. In the last one of our parts was coming onto half the page, and in this one, our entire part is coming onto the entire page. But in the end, you can see that we got all these values, so they input it into the matrix, and they've made matrix B. So I hope that makes sense. And yeah, this is the second part of that same question. Third part, just the exact same things over and over again with changed formulas. Now we are going to do question number 3 after a little food break for me. So if you guys want to go eat food as well. Food is good for you. Okay, so we are going to continue with question number 3. On the left side of my screen, you can see I have your guys' book open. May I quickly add that with this new book that they have added into our syllabus, or to your guys' syllabus at least, a lot of the answers that you will see in the back of the book will be wrong. A lot of them will be wrong, along with your stats book. If any of you are statistics students, then a lot of the answers in your statistics books will also be wrong. So please try not to depend on those answers. And if it really is that complicated, or you need the answers with you while you're studying, then you can go to this very same website that I found this exercise off of. I'm highlighting it right now. Math World PK. I'm not highlighting it. I'm underlining it. Math World PK. ठीक है, मैंने उससे सारी exercises की solution download किए हैं by Sir Rizwan Zafar. So you can check out this. This has all the solutions that I'm explaining from, and it also has the correct answers. So yeah, please do not depend on the answers in your book. And yeah, let's just continue. So question number 3, 4, 5, 6, and well, not 7. Well, up till 6, we have around the same questions. ठीक है, तो ये चारों questions एक जैसे ही हैं. I'm going to start with question number 3. So if matrix A is equal to this and matrix B is equal to this, then find a matrix C such that A plus B plus C should equal to 0. So if you look onto my solution side, I have written A plus B plus C, well not me, well Sir Rizwan has, is equal to 0. Tika, that's the given that they've given us. Now how are we supposed to find for C? All we're going to do is we're going to take A onto this side, and we're going to take B onto this side as well. Okay, so we're left with C alone. As you know, when you switch sides, the value signs also change. So C is now going to be equal to 0 minus A minus B. I hope that makes sense. So the matrix you can take for 0 is just going to be a 3 by 3 filled with a bunch of zeros because it has the exact same meaning, minus our A matrix and our B matrix. Now, यहाँ पर they've subtracted all of them at the same time. But my recommendation to you would be to subtract them one by one, so it's easier. Or exam, maybe, I think you should subtract them one by one. So you're going to first just like pretend B isn't here. You're going to first work with 0 and A, and then you'll add B in to whatever you have later. I hope that makes sense, and this is the remaining matrix that you have formed. That is your answer. Now we're going to move on to question number 4. Find A, okay, so part 1, question number 4, part 1. Find a matrix such that this first matrix multiplied by A multiplied by the third matrix is equal to an identity matrix. Now, unlike the last question where they named the matrices A, B, C, D, whatever, they haven't named them here. So we're just going to name them ourselves. Over here, you can see that they have been named. B is blue. I can't do this. Why can't I do that? B is blue, I'm just gonna mark it off as blue. A is red. This is what we have to find. C is yellow, a very disgusting yellow. And D will be green. Okay, so they've marked off all the matrices on our own. Instead of just marking them off like they have, you have to write let B be equal to this, let C be equal to this matrix, let D be equal to this matrix. Because if you don't write let, they're going to, the examiner is going to assume that you just gave these random letters, which is not what we want to do. Now once we've done that, we can just write the simplified form of this entire thing with the letters that we've given them. So B into A into C is equal to D. All right, that is what they have given us basically. Now we need to find A, so we're gonna take A alone. Now everybody knows, यहाँ पर तो उन्होंने सीधा सीधा लिख लिया, but I'll try and explain it. B into A into C is equal to, is equal to D. Okay, so let's take B onto the other side first. A into C is equal to D divided by B. Okay, now we know that we cannot divide matrices. All right, we just don't do that. So what we do is we're gonna take B onto the top. So it'll be D into B inverse. Now, why do we take inverse? The power on this B originally, is 1. Now, when we bring the B onto the top of the fraction, it'll become a negative. So it's going to be -1, which we call inverse. If it was a square, it'll become -2. All right, over here it would become -2. So yeah, that's all I'm trying to explain, why we did the inverse. Now we're going to do the same with the C. So A is equal to D into B inverse over C. Again, we're just going to bring that to the top. So A is equal to D into B inverse into C inverse. All right. Now over here, obviously they've written it neater than I have. I'm just going to erase all of my working. They've written it as B inverse into D into C inverse. You don't have to do the brackets, but it's easier to understand if you do it separately. Now, again, you should have learned this in 9th and 10th. When you're finding the inverse of a matrix, there's a formula for it. So in this case, we're going to do B inverse first. B inverse is equal to adjoint of B over determinant of B. Adjoint is, let me just explain that. I hope you guys know what I'm talking about because this is very simple stuff. So suppose we have the matrix A, B, C, and D. Okay, adjoint is when you're going to be, let me pick a different color. For these two, oopsies, it's not color, is it? These two values, why isn't it letting me draw? There you go. These two values, in this case A and D, are going to switch places, okay? And these two values, C and B, are going to switch signs, all right? So as you can see over here, our original matrix is 2, 1, 3, 2. But since we're taking the adjoint, we've switched the places of 2 and 2, which because they're the exact same, you can't really see the difference. They're the same number. And we've changed the signs of 3 and 1. So it's now -3 and -1. Hope that makes sense. That's how you take an adjoint, which you guys should know, but I'm just explaining in case we have any dummies here. I'm joking, none of you are dummies, you all are very smart people. Taking the determinant now. Determinant is just denoted by these two bars that you put outside of your matrix or outside of your letter. For determinant, you're going to multiply two values and then subtract them from the other two. So we're going to multiply 2 and 2, which is 4. Okay, they've written it already over here. 2 and 2. And then you're going to multiply 3 and 1. Okay, which is, as you can see, 3. Now when you have those two values, you're just going to subtract the second one from the first one. So 4 minus 3, as they've done over here, which is equal to 1. So that's the determinant of this matrix. Okay, I hope you guys already, again, know how to do this stuff, but just in case you didn't, I've explained it. Now, you figured out the adjoint, you figured out the determinant to put into this formula. So this is the adjoint over our determinant, which is 1. And once you solve it, you can divide matrices by a singular number, but you cannot divide a matrix by a matrix. As I said before, you cannot divide a matrix by a matrix. So in case you're confused, oh, why are we dividing now? You can divide a matrix by a singular number, but not another matrix. So in this case, they haven't shown the working, but this is what it would look like. 2 divided by 1, minus 1 divided by 1, minus 3 divided by 1, and again 2 divided by 1, which becomes 2, minus 1, minus 3, and 2, because anything divided by 1 is itself. So yeah, that is how you found the inverse of B, all right? That's one part of your solution done. Now you have to find the inverse of C, okay? So we're going to do the exact same thing, the exact same formula. You found the determinant, you found the adjoint, you're going to put it into the formula, and this one is divided by negative 2. Now over here, they've simply wrote 1 over negative 2 into the matrix, which is another way to write this entire thing. However, you don't have to do this, and you can directly divide it, which I find easier. So if it was me, I would have directly divided this. 4 by negative 2, minus 3 by negative 2, minus 2 by negative 2, and 1 by negative 2. And the answer would have left you with negative 2, negative 3 by 2, negative, sorry, not negative 1. Negative and negative is positive, so positive 1, and negative 1 by 2. That would have been your answer. But if you want to do it this way that they've shown, you can also do it that way. Now, you found your C inverse, you found your B inverse, and of course you already have a D. So you already have a D, sorry. And you're just going to put it into the formula that we made beforehand. You're going to solve the entire thing, multiply B inverse and D first, and then multiply that value with your C inverse, and in the end you are left with A. Okay, so I hope that made sense to all of you. And we are just going to move on to question number